Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I would like to talk to you about one of my articles entitled Sunspots and the Sun. Now, sunspots are regions on the surface of the Sun where the magnetic field line, the Sun's magnetic field, is very intense or very strong. And the way we see that it is very intense is that the magnetic field lines are very close together. So we see here some areas of sunspots, and this is where the magnetic field lines are closest to each other. So these are areas of intense magnetic field. Now, as a result of the intense magnetic field lines, a large amount of ionized particles spiral along these field lines and are therefore taken high above the sun's surface. These field lines are also looping in shape and form what's called plasma loops, whilst the surface of the sun, which is called the photosphere, is left with a hole in it. So a sunspot is really a hole in the sun's surface through which we can see the sun's interior. These holes are often larger in size than the Earth, and we see here a figure where we see a sunspot. The dark part is called the umbra, and the region around that, it's darker than the photosphere, but not as dark as the umbra, is called the penumbra. And here we have the sun to provide a size comparison. You see that a few sunspots are larger than the sun. Now, we also have smaller sunspots, and these are called pores. These are the smaller sunspots. The sides of the sunspots have steep inclines, and we can see here in the side view that this is indeed very steep, going through the photosphere into the sun's interior. Now, because these sunspots are dark and also cooler, the temperature inside a sunspot is about 2000 degrees Kelvin below what it is on the surface of the sun. So at the surface we have a temperature of 5700, and the temperature inside is 2000 degrees lower. Now, because the sun's interior is therefore dark and cool, we cannot have that the sun is powered by nuclear fusion from its core. Because if there were fusion reactions occurring deep inside the sun, there would be light and heat coming out from the interior of the sun. And so these sunspots would not be dark. We would see light in the interior. So because magnetic field lines have to form closed loops, they come in pairs. So we have always a pair of sunspots. One is called a north polarity sunspot, out of which the sun's magnetic field lines flow, and the other one is called a south polarity, and the magnetic field lines flow into that one, because magnetic field lines have to form closed loops, so the loop would close inside here somewhere. In addition, the sun has a 11-year cycle, and this leads to a variation in the number of sunspots. It increases during the solar maximum, and it decreases during the solar minimum. And in addition to that, the sun also has a polarity cycle, which is 22 years long. So it's double the period of just the sunspot cycle. And the polarity cycle is a reversal of the sun's polarity, which can be seen by which sunspot is leading a sunspot pair. So we see here in cycle A, we would have the north polarity sunspot leading the sunspot group as the sun rotates in this direction. And each cycle is 11 years long. So in the next cycle, which would be cycle A+1, we would have that reversed. And the leading sunspot is now a south polarity sunspot in the northern hemisphere. It's actually reversed in the southern hemisphere. if the south is leading in the north hemisphere, then the north polarity sunspot would be leading in the south hemisphere of the sun. So now we have a 11-year cycle here. We have another 11-year cycle there. And then in the next cycle, cycle 8.2, we would go back to the same polarity that we see here. So it would take 22 years for the sun's cycle to go back to the original setting. In other words, it's a 22-year polarity reversal cycle. Then we can see the polarity of sunspots in images called magnetograms. And these magnetograms, if they are in black and white, the south polarity sunspots are in black and the north polarity sunspots are in white. However, if we have a colored magnetogram, the green is the south polarity sunspots and the yellow is the north polarity sunspots. Now, since magnetic field lines are so close together in areas of high numbers of sunspots, these field lines become prone to magnetic reconnections, and these lead to explosive releases of energy, which we call solar flares. So in this figure here, there's an illustration of what happens when these reconnections and solar flares occur. So what we have is the magnetic field lines grow outwards from the surface of the sun, and then the inner field lines start pinching, and then they get very close together, and that leads to a reconnection. So you see here that the magnetic field lines separated. So we now have these closed field lines here, and we have a smaller looping field lines here. When this happens, huge amounts of energy are released in the form of solar flares. And it also leads to plasma being released into space at speeds of up to 1,000 kilometers per second. So this is what then leads to CMEs, because plasma, the release of plasma which separates from the sun's corona and accelerates outwards away from the sun, is basically a CME. Now, conventional theory states that the sun is powered by fusion reactions, and as I mentioned before, I don't think that is possible because sunspots are dark. But another reason is the observation that the sun can actually stop emitting light from its surface. And this happens during the Solar Dynamics Observatory eclipse season. So at this time, twice yearly, the sun goes completely dark for up to an hour a day and for about 20 days. However, this does happen at other times, but the sun does not seem to go completely dark at other times. It seems to go partially dark. And this is often hidden by cutoff lines, but if you examine the images carefully, you can still see that the sun has lost light emission. So now we're going to look at some images from the beginning of the cycle in 2017. So this cycle started on February 14th, and it started at 7:13 UTC, and the sun reached maximum darkness in the 17.1 nanometer wavelength at 7:21. It sometimes varies a little bit from when the maximum darkness appears in the other wavelengths. So, but we're going to look at images in the 9.4 nanometer, which are X-ray images, and in the 21.1 nanometer, which is ultraviolet. And both images at 7:16. And we see the images down here. This is the X-ray image. This is the ultraviolet image. We look at the timestamps 7:16:23 and 7:16:22. Now, the Earth absorbs X-rays. The Earth's atmosphere absorbs X-rays. So it's not possible to see any portion of the sun through the Earth's atmosphere in X-ray radiation. So that means that the Earth would be covering this part, including its atmosphere. No extra portion of the sun could be seen because no X-ray light goes through the Earth's atmosphere. However, in ultraviolet, it's possible that a little bit of light goes through some of the Earth's atmosphere. So in which case we would expect to see more of the sun's surface in ultraviolet light. So we'd see either exactly the same or a bit more. But what we see in these two images is that you actually see less a portion of the sun in ultraviolet than in X-rays. And this is not possible if this is due to an eclipse. This is impossible. As you can see, this bright region here forming a type of S is below the boundary between darkness and light in the X-ray image, but here it is actually above the boundary. And this in itself, to me, always indicated that this is not an eclipse. There are complete sections of plasma that are emitting light. We don't see this section partly covered by the sun's, by the Earth's surface. We would expect this to be covered, or some parts of it, so we wouldn't see a completed feature on the sun. We would see a cut off along certain features, and we don't see that. We see complete features even beyond the boundary of darkness and light at this edge. Now, the other thing that we can look at is the fact that this image is from slightly later than that one. This is 1 second later, and the sun is getting darker. So we would expect to see a lesser portion of the sun in the later image. And again, this is reversed. So that's one of the clear reasons why it cannot be a solar eclipse. The sun is not being eclipsed by the Earth as far as SDO satellite is concerned. That's not possible. But another irrefutable, and this is absolutely irrefutable reason, is what happens to the corona. So we have these images are in 21.1 nanometer, and they are 1 minute apart. So this is from 712, this is from 713, this is from 714, and this is from 715. And the sun is getting darker at that time, so the darkness is progressing. So we see a larger portion of the sun in the 714 image than in the 715 image, as it should be. But what else do we see? We actually see the corona shrinking. So if this was due to an eclipse, the corona would be covered. So we would see the corona covered by this, the Earth. But we don't see that. We can compare the size of the corona. So the boundary here is way above here. You only see a little portion of the sun that's not visible there. So the boundary is there. And yet, if we compare the size of the corona on this side from the earlier image with that one, it has obviously shrunk towards the surface of the sun. And this cannot be caused by an eclipse. And again, if we compare this image with that image, so let's look at the sun over here. You can see if we compare the size of the corona here with the size of the corona there, it has obviously shrunk. It's shrunk back towards the surface of the sun. It has not been covered. It's shrinking ahead of the advancing darkness. And again, if we compare this image with that image, you see what it looks like there, and we see what it looks like there. Again, the corona has shrunk back towards the surface of the sun, and this is way ahead of the advancing darkness. And this is an irrefutable argument that shows that the sun is not being eclipsed. The sun is going dark. So this means that the sun cannot be powered by thermonuclear reactions, because then there would be light coming from the interior of the sun all the time, and it would never stop emitting light. There would always be light coming out of it. So this shows that the sun cannot be powered by fusion reactions from the interior. But what is happening, and I believe is happening is that it is having fusion reactions at the surface. And this in turn requires that these fusion reactions happen at much lower temperatures than is thought possible. But if the sun has electrical potential energy, then fusion reactions are possible at very low temperatures. This process is called cold fusion or low energy nuclear reactions, LENR for short. Now this suggests that the sun has to be electrical in nature. And I don't believe it is powered from the outside. I believe that the sun is, or stars are formed with a certain amount of energy. And why I believe that is because stars age. They go through a changing process. And that is an aging process that leads to the formation of stellar cores. They go through a red giant phase, a white dwarf phase. They end up stellar cores, dark, infrared, mainly infrared emitting objects, which can, however, rejuvenate when they absorb energy and plasma from main sequence stars. They do also absorb energy from each other, but they can only really rejuvenate when they can get energy and plasma from a young star, a main sequence star. So stars have to be able to age in order to go through these different phases and end up stellar cores. And that means that their energy has to decrease, which means they must have a finite amount of energy to start off with. So this shows that the sun must be electrical in nature, that it must have a certain amount of energy. So it's like a battery, generates electrical potential energy, and it uses that energy to ionize its particles. So for instance, hydrogen would be ionized and turned into protons and electrons. Then these particles would flow in the sun's layer called the photosphere, which is 500 kilometers deep. And so the depth of the canyons would be about that size. And these particles, because they flow and they are charged particles, they would form currents, and currents generate magnetic fields. And we can see here in figure 8 that if you have a solenoid and a current flows through the solenoid, then this type of magnetic field is generated. It looks like a bar magnet magnetic field, but it's actually generated by a current, or in other words, charges flowing along this wire that's formed into a solenoid. And so these types of currents would form eddies or tornadoes in the photosphere, as illustrated below. So we would have these objects flowing like this. This is in the form of an eddy or a tornado. And then we would have the magnetic field formed in this way, and it would form closed loops. Some of it would stick out of the photosphere, out of the surface of the sun, and then particles spiraling along these would give the impression that this part is covered in plasma, so it would look like plasma loops. So the sun cannot be powered by thermonuclear reactions from its core, which what then would cause the gravitational, what cause stars not to gravitationally collapse, because what is supposed to keep them from collapsing gravitationally is the fact that they are having fusion reactions from the core. And now it becomes obvious that they cannot be having these fusion reactions. So what does this show? This shows that the gravitational interaction does not seem to be playing much of a part in stellar formation and in what powers a star. There does not seem to be any gravitational attraction inside the star, because otherwise the star would collapse. So the forces at play seem to be the electrical and the magnetic forces, and I've talked about that it could be that there is some type of strong force as well. that is causing these objects to be attracted, or these stars to be attracted to each other. So in conclusion, sunspots are complex structures on the surface of the sun associated to the sun's magnetic field. Studying sunspots leads to the conclusion that the sun is dark and cool on the inside, and that it is powered by cold fusion on its surface. In addition, the sun seems to be powered by internal electric potential energy, and gravity does not seem to play a part in its functioning. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.